All right, guys, this is our video for this week's homework. First, we're going to write the decimal as a fraction. Whenever we look at this decimal, we know that our 7 is in our tenths place. So when we say this decimal, this is 7 tenths. So 7 tenths. Okay. Next one, we have our tenths place, and then our hundredths. We have no tenths, but 3 hundredths. So when we say this decimal, it is 3 hundredths. Okay. Next, find the missing number to make these fractions equivalent. Remember, we use multiplication whenever we're trying to find equivalent fractions. So 4 times what equals 12, and whatever you do to the bottom, you have to do to the top. So if you were to write down your multiples, if you don't know them automatically, that's 4, 8, 12. So 4 times 3 equals 12. And then 3 times 3 equals 9. Okay? Keep that in mind because I want you to do that for this next one. Whatever you do to the top, you must do to the bottom. So 2 times something equals 14. And 6 times something is going to equal whatever our denominator needs to be. Remember, whatever you do to the top, you must do to the bottom to find our equivalent fraction. Next, we have to find the product, okay? Product is the answer to a multiplication problem, and we can use our area model to do this. Oh, hold on, I'm gonna make the shape a little bit better than that. Seven, and then we're gonna decompose 6,843. So there's 4 place values, and that's 6,843. And you're going to do 7 times 6,000, 7 times 800, 7 times 40, 7 times 3. Okay? I broke it down for you. I want you to write your multiples of 7. So 7 times 1, 7 times 2, 7 times 3, 4, and so on. Here. Times 5, 7 times 6, 7, 7 times 8, 7 times 9, right? We're going to write down our multiples of 7. I'm not going to tell you them because I really want you to practice those multiples. I know 7s are hard, but we can do it. Write down your multiples of 7, and then multiply using your area model. And then remember, after you figure out all of your partial products, we have to add them up. Okay. Next, write this number in expanded fraction notation. Okay. Fraction notation is very important. First, always, always, always write your place value chart. So we have our ones, tens, hundreds, thousand, 10,000, and then tenths, hundreds, or hundredths, sorry, tenths, hundredths. And when we're writing an expanded notation, remember we're stretching it all the way out. So we start first, 5 times 10,000. plus, we don't have a digit. Well, there's a digit, but no value in our thousands place. So we're going to move on. Our next value is 400. So we have 4 times 100. No value in my tens or my ones. So I'm going to move on to the tenths place. And that is 1 times 1/10 plus 7 times 100. Okay. Next, we are using the protractor to determine the measurement of the angle. Okay. So when I look at this angle, I'm going to zoom in, and y'all can do this when you're taking your test as well. You're either going to use the numbers at the top or the numbers at the bottom. No mismatch, okay? So when I'm looking here, my first ray crosses through 150 degrees. And when I look at my second ray, it is crossing through 65 degrees. Okay? And what I'm going to do is find the difference. So 150 minus 65 divided minus 5. We can't do that. So my 5 in my tens place is going to become 4. The 0 in my ones place is going to become 10. 10 minus 5, 5. 4 minus 6, again, I can't do that. 14 minus 6. Eight. So this angle is 85 degrees, which is an acute angle. Okay. All right. How many lines of symmetry does this figure have? Mr. Henderson's putting a start because I want you guys to work this out. I am going to help you. Remember, I'm going to give you a little example. Lines of symmetry means that when I fold it on that line of symmetry, both sides are going to look the exact same. So here, we'll use this triangle as an example. It's not perfect. I'm going to try to make it as perfect as possible, okay? And then when I draw my line of symmetry, when I draw my line of symmetry, it should be relatively the same on both sides, okay? Miss Henderson is not a computer, but I tried my best. But you guys can see that if we were to fold this triangle one time, it should be the same on both sides, okay? So that line of symmetry means that when I fold it at that line of symmetry, it is the same on both sides. When y'all look at this figure, I want you guys to make those lines of symmetry on there. Nick rides the bus home from school in the afternoon. He leaves school at 4:07 p.m. and gets home at 5:02 p.m. How many minutes does it take Nick to get home? Okay, so we are starting at 4:07. That's our start. And our end time is 5:02. Okay, so we know that for it to be a complete hour, it would be 60 minutes, right? So if we were to go from 4:07 to 5:07, that would be one complete hour or 60 minutes. Now, We are not going a complete hour because he got home at 5:02. So there's two ways that we can solve this. You could do mental math. You see, oh, a complete hour would be 5:07. We only have 5:02. What is the difference? 5 minutes. So 60 minutes minus 5 minutes equals 55 minutes. It took 55 minutes for him to get home. If that is a little complex, that's okay. Let's make this into an easy number. We can do it on a number line, right? So 4:07 is an awkward time. But what's not awkward is if we were to add 3 minutes. So let's act like 4:07 is my starting point on my number line. And I'm going to just add 3 minutes. Okay? That makes my time 4:10, right? Well, 10 is no longer a hard or an awkward time to work with, right? If I wanted to add 50 minutes to 4:10, so plus 50 minutes, that puts me at 5 o'clock because 10 plus 50 is a complete hour, so it gets me to the next hour. And then from 5 o'clock to 5:02, that is plus 2 minutes. And then we can add all of these time intervals up, which would be 50 minutes plus 3 minutes plus 2 minutes, 55 minutes. And so it took Nick 55 minutes to get home. And those are just two different ways that we can solve it. A number line or like mental math. 5 friends went to lunch and spent $75. They shared an appetizer that Cameron paid for. They split the rest of the bill evenly. How much did each friend pay? Okay, so we are going to create a strip diagram. We have 5 friends that went to lunch. One, two, three, 4, 5 friends that went to lunch, and their total that they spent was $75. But they shared an appetizer that Cameron paid for. So out of that $75, 5 of those dollars Cameron took care of. They split the rest of that bill evenly. So how much did each friend pay? My first step, I need to take out that $5 that Cameron paid for. So that would be 75 minus 5. After that, they split the rest. So that is divided by 5. Okay. 75 minus 5, equals 70. And then we need to do 70 divided by 5 equals the amount. I want you guys to solve this part independently because that's, you can either count by 5s until you get to 70. You could do long division, or you can do the dot method, whichever one you're comfortable with. All right, the 3rd grade students at Jones raised $144.36 for a new playground equipment. The 4th grade students raised $116.08, and the 5th grade students raised $272.70. How much more money did the 5th graders raise than the 3rd and 4th graders raise in all? Okay, so let's go ahead and represent everything. We have our 3rd graders who raised $144.36. And, because here in our questions it says third and fourth grade, meaning they're going to be together. Fourth grade raised $116.08. And fifth grade raised $272.17. And we are looking, oh, that was not cute. We are looking for the difference between third and fourth grade and fifth grade, right? So what we have to do first, if you go back to our question, it says how much more money did fifth grade? So we know fifth grade had to have raised more than third and fourth grade together. So first we have to figure out, well, how much did third and fourth grade raise together? And to figure that out, we have to add. And then after we add, we are going to subtract. Well, fifth grade is the greater amount. So we would have $272 and $17 minus whatever third and fourth grade raised together. Minus, okay? When we add them, we need to stack. So first step, let's do it. $144 and 36 cents plus $116 and 8 cents. 6 plus 8, 14. 3 plus 1, 4. Look how Miss Henderson is lining up her decimals. 4 plus 6, 10. 4, 5, 6. 2 plus 1 plus 1, 2. Good. So third and fourth grade raised $260.44. And our next step is to subtract that from fifth grade. So that's $272.17 plus, no, sorry, minus $260.44. 7 minus 4. Actually, I want y'all to solve this part by yourself. We need to practice with that subtraction. I know y'all got it. So make sure that you subtract. Remember all of our rules of subtraction. And y'all got it. All right, last but not least, it says circle 6 correct attributes of the shape. Attributes are like characteristics or descriptions of our shape. So when I look at this shape, I would go ahead and make some observations before I even look at my answer choices, right? I see that this shape has 4 sides. I see that this shape has 4 right angles. I see that this shape has 2 sets of congruent sides. I see that this is a closed shape. Okay, so let's look at our attributes that were listed. Polygon. Polygon is just a closed figure. So does that check out? Is this shape a closed figure? Absolutely. With no curves. Okay. Is this shape a rectangle? What makes a rectangle a rectangle? A rectangle has to have 4 right angles. And our shape does have 4 right angles. Is this shape a quadrilateral? A quadrilateral has 4 sides. And yes, we said, oh, it does have 4 sides. A parallelogram. What is a parallelogram? A parallelogram is a shape with two sets of parallel sides. Well, these sides are parallel, and then these sides are parallel. So yes, this is also a parallelogram. A trapezoid only has one set of parallel sides. So no, can't be a trapezoid because we already said that this has two sets. So a trapezoid, no. For congruent. Congruent means the same. No, all of our sides are not congruent. It has two sets of congruent sides, but not all four sides are congruent. So no. Two acute or two obtuse angles. Nope, we said that it has four right angles, so can't be that. Four right angles. Yes, it has four right angles. All right, so far we know that's a polygon, rectangle, quadrilateral, parallelogram, a right angle. It is not a rhombus. Okay. 1, 2, 3, 4, 5. So we need one more attribute. A square. A square has to have four equal sides and four right angles. So is this a square? No. And like we already said, it has two sets of parallel lines because if it's a parallelogram, that means that it has two sets of parallel sides or lines. Okay? I hope that this video helps. Y'all have a great day.